everyone. This video will show how to determine if the given table of values is an example of a direct variation or not. Before we go further, please feel free to check out the description below for the link of the other series of topics related to direct variation. Before we go over some examples, let's have a review on the definition and real-life examples of direct variation. We remember that, by definition, direct variation is a type of proportionality wherein one quantity directly varies with respect to a change in another quantity. To better understand this, let's look at variable A and variable B. For a direct variation, if variable A increases, variable B will also increase. Now please notice the direction of the arrow. Both of them are increasing. On the other hand, if variable A decreases, then variable B would also decrease. Again, please notice the direction of the arrow. Both of them are going down. Again, please notice that for a direct variation, both variables have to increase or both variables have to decrease. So whenever we see these type of relationship where both variables increase or decrease, we can go ahead and say that A varies directly as B, or we can also state this as A varies proportionally as B, or A is directly proportional to B. Now let's take a look at some real-life examples of direct variation. Okay, the number of hours you work and the amount on your paycheck are directly proportional to each other, which means that if you work more hours, then it means that you get more money. On the other hand, if you work less hour, then it means that you get less on your paycheck. So again, the number of hours you work is directly proportional to the amount of your paycheck. Now let's take another example. The speed of a car and the distance traveled in a certain amount of time are directly proportional to each other, which means that if a car travels faster, then it can travel more distance. It can cover more distance at a given certain time. On the other hand, if a car travels slower speed, then it can cover less distance. This tells us that the speed of a car is directly proportional to the distance it traveled at a certain amount of time. Okay, going back here, we remember that the general equation of a direct variation is y equals kx, where our k is the constant of variation or the proportionality constant. From this equation, we can go ahead and determine the equation for k. So we have to divide both sides by x. I'm going to divide this by x. I will divide this by x so we can cross this out. We can go ahead and say that the k value or the proportionality constant for a direct variation is y over x. We are going to use this to determine whether or not a given table is a direct variation or not a direct variation. So let's use this equation that we have here in the next example. Okay, in this problem, we are asked to determine if the given table of values below is an example of a direct variation or not. If so, we're supposed to state the constant of variation and we write the equation. So in order that we can determine if this given table that we have here is a direct variation or not, we remember that the formula for k shall be used to determine if it's a direct variation or not. We remember that k is equal to y over x. So we are going to determine the k values for each of these ordered pairs. So we can go ahead and say that the k for the first one is our y is 12 divided by 3. 12 divided by 3 is 4. The next k value that we have here would be 20 over 5. Again, that's y over x. So 20 divided by 5 is 4, and then we have k is equal to 32 divided by 8 is 4, and then we have k is equal to 40 divided by 10 is 4. So we can go ahead and say that our constant of variation or the proportionality constant is 4. In order that we can write the equation for this table that we have right here, we remember that the general equation for direct variation is y equals kx. So we can go ahead and plug the value of k into the equation, and that is the equation for this direct variation. So that would be y equals, our k is constant, which is 4, and we write x. So this is the equation that would work for this table. Again, this is an example of a direct variation because it follows the general equation of a direct variation, y equals kx. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're supposed to determine the k or the proportionality constant. The equation is k equals y over x. So I'm going to go ahead and show the work for the k for each of these ordered pairs. I'm going to start with the first one. Okay, since we determined the value of k is -2 for each of these ordered pairs, we can go ahead and say that this is an example of a direct variation with a k value of -2. To determine the equation, again, it has to follow the general rule for direct variation, y equals kx. So then we go ahead and plug the k value in, so that's y equals -2x. So this is the equation for this direct variation. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example. Okay, in this example, we are given a horizontal table. Even though the table looks different from the first two examples, the same rule would apply. So again, in order that we can determine if it's a direct variation or not, we're supposed to determine the k value or the proportionality constant or the constant of variation. And the equation for that is k equals y over x. So I'm going to go ahead and determine the k value for each of these ordered pair. So our k here would be y is 11 over 6. If we use calculator for that, that would be approximately 1.83. And then the k again for the next ordered pair would be 9 over 4 using calculator. 9 divided by 4 is 2.25. So I write it down here. And then the k for the next one is 4 over -1. So that gives us a -4. And then the k here would be y, which is 0 over -5. Our k value is 0. If you notice, all the k values are not the same. So that tells us that this is not an example of a direct variation. Since this is not a direct variation, we're not going to write the equation for this. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're supposed to determine the k or the constant of variation, and that would be k equals y over x. And we're going to show the work for all of these. Okay, I have divided y over x for each of these ordered pairs, and we determined that the k value is 5 for all of them. This tells us that this table is an example of a direct variation since our k value is the same for all of these ordered pairs. So I'm going to go ahead and write it down here. Okay, since this is a direct variation, it follows the general equation y equals kx. We solved for k, which is 5. So then this is y equals 5x. So this is the equation for this table that we have up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya.